Hello and welcome to Algebra 2 by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 1 on algebraic expressions. Throughout this course I will be doing some work on a graphing calculator and today just a tiny bit of numerical work. All throughout the course I'll be using the TI-Inspire calculator, not the CAS one with algebraic manipulation ability, but just the standard TI-Inspire. For today's lesson, you might want just a rudimentary calculator that will allow you to do some calculations. But let's get right into it and start talking about algebraic expressions. All right. Now, at the beginning of Algebra 2, of course, a lot of what we're going to be doing is reviewing material from Algebra 1 because you had that gap year in between with geometry. Algebra is the branch of mathematics where we solve problems by representing unknown quantities or variable quantities using letters, variables, and then using the properties of numbers to manipulate these expressions to solve the problem at hand. So let's start off by looking at some basic definitions. All right, so to begin, a variable. Right? A variable is a quantity that is unknown or can change within the context of a problem. Most often, variables are represented by a letter or a symbol. Terms. A term is a single number or combination of numbers and variables using exclusively multiplication or division. This definition will expand when we introduce higher level functions. And finally, an expression is simply a combination of terms using addition or subtraction. All right. Now, in mathematics, terminology is important, right? You want to understand what a variable is, what an expression is, etc., etc. But ultimately, right, getting past all the terminology, we just need to be able to do problems. So let's take a look at exercise number 1. Given the expression 5x squared minus 2x plus 10, do the following. Letter A. How many terms does this expression contain? Now, a term is kind of important, right? A term is simply a combination of numbers and variables using exclusively multiplication and division, all right? So for us, right, we've really got 3 terms. We've got 5x squared, we've got 2 times x, and we've got the number 10. Now, a lot of math teachers will say, well, actually what we've got are 5x squared, negative 2x, and positive 10. And that's fine. Any way you go about doing it, though, the plain fact is we have 3 terms, all right? There are 3 terms in this expression. Now, whether or not you consider them 5x squared, positive 2x, and positive 10, or 5x squared, negative 2x, and positive 10, for right now, doesn't really matter. The point is, we want to think about each one of those 3 things that I circled as being sort of an individual element in the overall expression. Now let's take a look at letter B. Evaluate this expression when x is equal to negative 2 without using your calculator. Show the work that leads to your answer. Now, a lot of times I'm going to ask you to do problems without using your calculator. Obviously, if you're weak with arithmetic, you can use your calculator. My point, though, in saying to not do it with your calculator is because it will be something that you can do without your calculator, or you should probably be able to do without your calculator at this point, and it's going to give you practice in numerical skills. Now, all that being said, right, when we want to evaluate an expression, the idea is that this expression contains the variable x, right? And it has no value until we say, the value of x is the following. In this particular case, the value of x is negative 2. So let's substitute it into our expression and figure out what the value of the expression is when x equals negative 2. Let's go ahead and do that now. All right, so what I'm going to do is everywhere there's an x, I'm going to put in a negative 2, and I'm going to put it in parentheses. That's never a bad idea. Now, order of operations tells me I should square that negative 2 first, and a negative times a negative is a positive, all right? I can also do negative 2 times negative 2 here, and I can get positive 4, and then I'll get plus 10. Now again, my order of operations says I should do that 5 times 4. That gives me 20, plus 4 plus 10, and now I can do 20 plus 4, 24 plus 10 gives me 34. All right. Notice that what we're really doing, right, and this is why terms are terms, is that each term kind of gets evaluated individually. Of course, there's nothing we have to do to evaluate the number 10, and then we combine those terms, in this case, using addition, all right? So we end up getting 34. Now, this expression can take a whole variety of different values depending on what the value of x is. Let's take a look at another expression in exercise number 2. Given the expression x squared minus 2x minus 8, do the following. Letter A, evaluate the expression for x equals negative 4. All right, since we've already done one of these together, I'd like you to pause the video now and go ahead and evaluate this expression when x is equal to negative 4. Take a moment. I'm sorry, it's x equals positive 4, not x equals negative 4. Let's take a look at what the expression is equal to. All right, so just like before, we're going to put in positive 4, or we're going to try to put in positive 4 into this expression. First thing that we're going to do is we're going to square that 4. 4 times 4 is 16. We're going to do 2 times 4 and get 8, minus 8. All right, 16 minus 8 is 8, and 8 minus 8 is 0. All right, and let's take a look at letter B. Why do you think this value is known as a 0 of the expression? And I apologize, what I really should have said is, why do you think the value x equals 4 is a 0 of the expression, right? So specifically when I say this value, I mean the value x equals 4, all right? Why do you think that is known as a 0 of the expression? Pause the video now and see what you can write down. Zeros of an expression are very important, all right? And we'll get into their technical definition in a moment, but hopefully you said x equals 4 is a 0 because it makes the expression equal to 0. And it's kind of fun because, you think, oh, well, the only 0 should be x equals 0. But x equals 0 isn't even a 0 of this expression because it doesn't make the expression equal to 0. Anyhow, let's take a fundamental look and define what the 0 of an expression is. So zeros of an expression. A 0 of a single variable expression meaning that there's only one variable, it's x or it's y or it's t or whatever. A 0 of a single variable expression is any value of the variable that results in the expression being equal to 0. All right, zeros are very important. We're going to get into them more and more as the course goes on, and we're going to look at them more even in this lesson. But let's take a look at exercise number 3. Quadratic expressions, those that have a degree of 2, often have 2 zeros. What are the 2 zeros of the expression x squared minus 64? Justify your response. All right, I'd like you to think a little bit about this expression, x squared minus 64. All right, I'd like you to think about that and think about what 2 values of x, if you substitute in here, will end up resulting in this expression equaling 0. Pause the video now and see if you can think about that. Well, the only way this expression is going to be equal to 0 is if x squared is equal to 64, right? That's the only way. Now, I'm not solving an equation so much right now as just sort of thinking about it, right? X squared has to be equal to 64. Well, there are 2 numbers that when you multiply them by themselves give you 64, right? So if x is equal to 8, right, then 8 times 8 is equal to 64. And if x is equal to negative 8, negative 8 times negative 8 is equal to 64. All right, now you might be thinking, because, the square root of 64 is both positive and negative 8, and we'll get into some square root work in the next lesson. But for right now, right, I just want to be thinking about this, right? Okay, well, What can I multiply by itself? That's what it means to square a number. To get 64, well, 8 times 8 gives me 64, and negative 8 times negative 8 gives me 64. So the two zeros of x squared minus 64, that expression, are 8 and negative 8. All right, let's keep working with more expressions. Now, let's take a look at exercise number 4, where we look at a different type of expression. Consider the rational expression x minus 10 divided by x plus 2, or x minus 10 over x plus 2, as we often say. Letter A, what is the value of this expression when x is equal to 0? Do without a calculator. All right, yet again, what I'd like you to do is pause the video and see if you can figure out what this expression is equal to when x is equal to 0. All right, just a little numerical work here. We're going to substitute this in. We're going to have 0 minus 10 divided by 0 plus 2, which is going to be negative 10, right? 0 minus 10, and 0 plus 2 is going to be 2. Negative 10 divided by positive 2 will be negative 5. All right, so just a little bit of work, right, to get a sense for what we've got going on here. Let's take a look at letter B. Show that x equals 10 is a zero of this expression. Now, in order to show that x equals 10 is a zero of the expression, what you want to do is substitute 10 into this expression and make sure the expression has a value of 0. So pause the video and go ahead and do that. Now, never forget that fractions represent division, specifically the numerator divided by the denominator. And you've been seeing that, I think, since about 6th grade. So hopefully it's something that's very comfortable to you. But in this case, right, if I put x equals 10 in, I'm going to have 10 minus 10 divided by 10 plus 2. 10 minus 10 is equal to 0. 10 plus 2 is equal to 12. And 0 divided by 12 is 0, right? If I have 0 cookies that I divide up amongst 12 friends, each of them gets 0 cookies, right? So that is a 0 of the expression. All right, let's take a look at letter C. Think about what makes a fraction or division problem equal to 0. Why must x equal 10 be the only 0 of this expression? All right, well, let's talk about this together, right? When we have a fraction, the only thing that can make a fraction equal to 0, or a division problem equal to 0, is if the numerator is equal to 0, all right? Nothing in the denominator can make the fraction equal to 0. There's nothing that you can divide by that will then result in a number being equal to 0. Okay, so at the end of the day, a fraction can only be equal to 0 only equals 0 if its numerator equals 0. X equals 10 is the only value that makes x minus 10 equal to 0. Right? It's the only value. Right? There's nothing that I can possibly put into the denominator that will make this fraction equal to 0, and the only thing I can put in the numerator that will make it equal to 0 is x equals 10. All right, let's take a look at letter D. Explain why this expression will not have a value when x is equal to negative 2. We say that this result is undefined. All right, well, what I'd like you to do is pause the video, substitute x equals negative 2 into this rational expression, and see what ends up happening. And if you need to, also use your calculator to evaluate the final result, if you need to. Go ahead and pause the video and see what happens. All right, well, let's do it. So, if I put x equals negative 2 in here, I'll get negative 2 minus 10 divided by negative 2 plus positive 2. Negative 2 minus 10 is negative 12. Hey, my phantom red pen came out. And negative 2 plus 2 is equal to 0. So I get negative 12 divided by 0. Now, you might think to yourself, oh, that should be equal to 0. Except hopefully what you've learned over time, and this should have been reinforced a little bit in geometry with vertical lines, is that division by 0 will never result in another number. All right? Division by 0 is undefined or not allowed. Division by 0 is undefined. All right? And again, just for a moment, just a brief moment, think about why that is. If negative 12 divided by 0 was some number, let me just put the number symbol after it, right? If that was equal to something, whatever it would be, 10, 5, 0, Fred, I don't care, right? If negative 12 divided by 0 was equal to some number, then 0 times that number would have to be equal to negative 12. But 0 times any number is 0. And therefore, there can be no number that negative 12 divided by 0 is equal to. There just can't be. All right? So division by 0 is never allowed, which means the denominator of a fraction can never be equal to 0. All right, let's play around with these a little bit. Exercise number 5. For each rational expression, state its zeros and state values where the expression would be undefined. All right. Well, what I'd like you to do is, given what we just did in exercise number 4, try letter A. First, try to figure out what 0 or zeros it has, and then also try to figure out what values of x or value of x would make it undefined. All right, well, the only way that it's going to have a 0, all right, so the only way it's going to have a 0 is if x plus 6 is equal to 0. But that means its only 0 is at x equals negative 6. Now, it's going to be undefined whenever its denominator is equal to 0, right? So it's going to be undefined when x is equal to 4. All right. Pause the video and see if you can do letter B. All right, a little bit trickier, but should be no problem, right? Same idea, right? We're going to have a 0 if 2y minus 1 is equal to 0, or 2y is equal to 1, or y is equal to 1/2. All right, so a little bit more complicated there. Our 0 is going to be 1/2, but simpler, right? This is going to be undefined when the denominator is equal to 0, and that's just simply when y is equal to 0. Now, in both A and B, we had a single 0 for each rational expression and a single value where the rational expression was undefined. Letter C a little bit different. Let's take a look at that. Here we have x squared minus 25 divided by x squared minus 81. Here, because we've got quadratic expressions, ones with x squared, they're going to be more than one 0 and more than one location where the rational expression is undefined. So take a moment now and see if you can figure out what the zeros are and where what values make the expression undefined. All right, well, the zeros are going to occur where x squared minus 25 is equal to 0. And again, that's where x squared is equal to 25, and that will be either x equals positive 5 or x equals negative 5. On the other hand, let me just scroll down a little bit, it's going to be undefined. Same idea when x squared minus 81 is equal to 0. That means x squared would have to be 81, and that will be either x equals 9 or x equals negative 9. All right, so a little bit more complicated. Not too bad, though. You know, we're not doing anything too hard on our first Algebra 2 lesson. All right, last problem. Let's talk about multivariable expressions, or last concept. Most expressions that you're going to work with in this course will have a single variable. X and t are the most common ones. Sometimes they'll have a y, sometimes a c, a d, etc. But expressions can certainly contain more than one variable, and when they do, these are known as multivariable expressions. Kind of makes sense. Let's do a little bit of work with multivariable expressions. Exercise number 6. Evaluate each of the following multivariable expressions for the values of the variables given. Letter A, 5x squared minus 1/2 times y cubed for x equals 3 and y equals -2. Again, let's try to do these without our calculator, and let's do the first one together, and then of course I'll have you do maybe the more challenging one on your own. All right, so here we go. Let's do a little bit of substitution. All right, first things first, I'm going to substitute 3 in for x, and I'm going to substitute -2 in for y. All right, my order of operations say I should do those exponents first. 3 to the second power is 9. And -2 to the third power is -2 times -2, which is 4, times -2, which is -8. 5 times 9 is 45, and -1/2 times -8 is +4. So I find that that first expression is equal to 49. Okay, what I'd like you to do now is pause the video and see if you can figure out what the value of the expression in letter B is. All right, let's do it. So we've got this fraction. A is going to be equal to 8. B is going to be equal to -2. Well, that's an ugly looking -2 there. See if I can make that look just a little bit more like a 2. And then I'll have 8 minus -2 in the denominator. All right, here we go. Order of operations, I should work within the parentheses first. That's 3 times -2, which is -6. All right. In the denominator, I can change that subtraction to an addition. All right, now in the numerator, I've got 8 plus -6, which is +2. And that'll be squared. In the denominator, I'll have 10. 2 squared is equal to 4. And then I've got 10, and I can reduce that down to 2/5. I suppose you could also leave it as 4/10, or you could even have it as a decimal 0.4, all right, all of which are equivalent. Okay, so we should be able to evaluate multivariable expressions, single variable expressions, just using our standard order of operations that you've been learning since, well, about 6th grade. All right, let's keep going. Final little piece. Oftentimes multivariable expressions arise when we deal with formulas that we use to calculate something. You see these formulas in geometry, in chemistry, in physics, right? Many of you are probably even taking physics right now concurrently with Algebra 2. Let's take a look at a classic formula from geometry. Exercise number 7. The volume of a circular cylinder is given by the expression pi r squared h, where r is the radius of the cylinder and h is its height. Find the volume of a cylinder whose radius is 4 centimeters and whose height is 10 centimeters. Round to the nearest cubic centimeter. So all throughout this lesson, I haven't touched my TI calculator, but here I'll need it a little bit to figure out what the value of this expression is because it involves the irrational number pi. Pause the video now and see if you can figure out what the value of the volume of this circular cylinder is to the nearest cubic centimeter. All right, well first, let me just substitute all the numbers in before I even bring the calculator out. So we know that the volume is given by the expression pi r squared h. I hope I'm not scarring anyone from last year's geometry class. Right, I'm going to put 4 in for the radius. I'm going to put 10 in for the height. And if you really wanted to, right at this moment, you could just substitute this right into your calculator and allow it to figure out what the final answer is and then round to the nearest cubic centimeter. If you first wanted it in terms of pi, you could certainly first square the 4, that would be 16. You could then multiply the 16 and the 10 to get 160. And this would sort of be the volume, 160 pi, in terms of pi. This particular problem asks us to actually give the volume to the nearest cubic centimeter. So in that case, what I would need is a calculator. It wouldn't necessarily have to be a graphing calculator. You could probably even do this on your phone as long as it had the pi button, right? So what I'm going to do is just go in. I'm going to grab my pi. I'm actually going to put it in as this, 4 squared times 10. All right, and what I see, hopefully, it's very small on your screen, but I see that the volume is 502.654. Let me put that here, 502.654, etc., which means ultimately my volume is going to be 503 cubic centimeters to the nearest cubic centimeter. All right, that's it. Just a little bit of calculator work there. But more importantly, this idea that we've got all these formulas that arise in science, engineering, all sorts of different fields, economics, things like that, that have more than one variable in them. And often when we want to know the value of the expression, we have to substitute multiple variables in, values of multiple variables in, and then evaluate using the order of operations that we've been working with throughout this lesson and for the past few years. All right, let's wrap this up. So in our first lesson in Algebra 2, we really reviewed some very basic ideas, right? The idea of variables, expressions, evaluating expressions, the idea that there are certain values of variables that when you put them into an expression result in the expression being equal to 0. Those are known as the zeros of the expression. And in some limited cases, there are values of variables that actually don't result in an expression having any value at all, right? Those are values that make an expression undefined. And the only examples of those that we saw in this lesson were values of variables that resulted in the denominator of a fraction equaling 0. We also briefly looked at the idea of expressions having more than one variable, right, known as multivariable expressions. All of these concepts we're going to find ourselves using on a regular basis throughout Algebra 2. So really at the beginning of this course, even though the homework might seem easy, it might seem review from both geometry and from Algebra 1, you want to make sure you take it very seriously because it's going to lay the basis for more challenging material as we move on. For now, I just want to thank you for joining me for our first Algebra 2 lesson in eMath instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.